Okay, so good morning. So today we're going to make a diagram or free body diagram from a worded problem. So what are the steps to do? The first thing that we need to do once that we have already the diagram is to plot the forces acting on the object. Ano ba yung mga forces na nakaka-apekto sa kanya? Second, to draw a Cartesian plane parallel to the surface that the objects are in contact with. So we draw Cartesian plane. Then third, we redraw the Cartesian plane without the objects. And then finally, to realign the Cartesian plane so that the x-axis are on the horizontal. Okay, let's start out with this problem. So the problem states that if the coefficient of static friction between a wooden block and an inclined plane is 0.75, at what angle would the block start sliding? So with this problem, we already have the diagram in place. We have the coefficient of static friction, which is 0.75, and we need to determine what angle theta is. So what is angle theta? So we are not going to solve this, but rather we're just going to draw the free body diagram. Now, as I told you, the first thing that we need to do is to plot the forces. Ano ba yung mga forces na nakaka-apekto dito? So we have two objects, an object on a plane. So of course, if we have an object, that object will have mass, and that mass will be the weight. Okay? So from that term itself, merong weight si object. So we have the weight. Okay, wait a while. Okay, so we have the weight downward. So we have here the weight, which is equal to mass times gravity. We also have normal force, which is always perpendicular to the surface. So we have here the normal force. And since there are no other forces acting on it that is making it go down or making it go up, you could assume that what is making it as keeping it from moving would be friction. So we have another force on the surface, which is friction. Okay? So we already have the forces on the object. Next thing we need to do is to draw a Cartesian plane. So we draw a Cartesian plane by drawing some lines. So let's have the Cartesian plane to be green. So we have here Cartesian plane, which is always parallel. The x-axis should be parallel, parallel to the surface. So we have here the x-axis, we have the y-axis, which is perpendicular to the plane. So as you could see, we could transfer all of the objects, the forces rather, on the Cartesian plane. But what's important is the forces should originate from the origin. Okay. So let's try to redraw the Cartesian plane. The next thing we do is to redraw the Cartesian plane. So we have the Cartesian plane here. Okay. And then we draw the forces, or rather redraw the forces. So the forces acting on the object versus the normal force. So the normal force would be here. You have your Fn. The next is, of course, as I told you, it should be from the origin. The next thing is the frictional force, which is parallel to the x-axis. So we draw the frictional force once again originating from the origin. So this is the frictional force, and finally the weight. The weight should which should always be downward. Okay. So we have here the weight, which is equal to mass times gravity. Okay. Now we have here something that we need to know is that the angle theta here should be equal to the angle theta, which is also here. So how can we say that? How does it? How do we know that it is the same angle? So if we try to redraw this, okay, if we try to redraw the diagram, so redrawing the diagram, sorry if it's a little bit off. So we have, let's say this, we align the Cartesian plane on the plane itself. Okay, so we have the weight going down. So what we have here is two triangles. Okay. So theta here, okay, this is 90 degrees. So that means that on the other side here, this angle here, which is angle beta, should be beta should be, since this is 180 minus 90 degrees, which is the corner here. That means that what's remaining is 90 degrees for theta and beta. So that to find beta, so theta plus beta should be equal to 90 degrees. So that means that beta should be 90 degrees minus theta. Okay. So this is 90 degrees minus theta. So this one here, beta is also
Sir Raymond, magsisolicit din ako sa'yo Para to sa grade 2 foundation.
this is
700.
also the same as theta because these two, beta and the angle here, should be equal to 90 degrees. So they are complementary because they form rather a perpendicular line. So they are 90 degrees. So that means that beta plus theta plus this angle here should also be 90 degrees. So it will also follow here. So if beta is 90 minus theta, it should also say that the angle here should also be theta. Theta pa rin siya. Okay? So 90, since beta is 90 minus theta, this one here, let's say we don't know this angle. Let's have this as angle alpha. So if that's angle alpha plus angle beta should be equal to 90 degrees since they are also complementary. So if alpha plus beta is equal to 90 degrees, so alpha should be equal to 90 degrees minus beta. So beta is 90 minus theta, so alpha should be 90 degrees minus 90 degrees minus theta. So 90 minus 90 is 0. Then negative theta. This also here is minus theta. So negative minus theta should be positive. So alpha should also be equal to theta. Or let's try to draw that. That's 90 degrees. This becomes minus 90 degrees. Minus minus. This becomes positive theta. So cancel yung dalawa. Alpha is equal to theta. So that means that this angle here is also theta. Okay. Next thing we need to do is to realign the Cartesian plane. So how do we realign that? So let's put the x-axis, since this is the x-axis. Let's put the x-axis parallel to the horizontal. And of course, the y-axis should be perpendicular to the horizontal. Okay? Now, redraw the forces acting on the object. You'll see that. Of course, the normal force is still upward. So from the center, this is the normal force. From the center, we have your frictional force. And from the center, we have here weight, which is equal to mass times gravity. And this is angle theta. The last thing we need to do is to put everything in along the x and y axis. So that means that so that we could get the summation of forces along the x and y. So the last thing we do before we could solve this is to redraw. Okay? Redraw or get the components of W. So that we'll have here. So this should be okay. This should be Wx or the weight along the x, the component of weight along the x. And we have here the weight along the y. Of course, this is the same here, Wx and theta, that sign. So Wx, which is equal to W sine theta, and Wy, which is equal to, since this is adjacent or beside theta, so Wy, which is W cosine theta. So that is how we create a free body diagram from a diagram given. Okay, even if it's not given, you need to visualize it. And from that visualization, from your imagination, you should be able to redraw the diagram and draw from that diagram a free body diagram. Okay, so that's how we do. Those are the steps you need to make in order to create a free body diagram. Thank you.